The rocket processing system is designed to safely prepare the M55 rocket for destruction. The M55 rocket is 78 inches in length and contains 10 to 10.7 pounds of lethal GB or VX chemical nerve agent. The warhead contains 3.2 pounds of Composition B high explosive, and the rocket motor contains 19.4 pounds of propellant. In 2018, the ACWA program initiated an assessment of the existing rocket processing system. This assessment revealed an increased reliance on personal protective clothing for worker safety, rather than engineered system design and administrative controls, resulting in reduction of the worker safety margin. In January 2019, the Undersecretary of Defense for Acquisition and Sustainment approved pursuing mitigation actions. This led to the evaluation and subsequent decision to use a static detonation chamber, or SDC, to destroy M55 rockets containing nerve agent. Another transactional authority contract action was taken to procure an SDC 2000 and modify the existing SDC 1200 at the Bluegrass Chemical Agent Destruction Pilot Plant. The OTA also includes the rocket warhead containerization system, making the warheads amenable for processing in an SDC. In March 2020, an advanced surveillance of the M55 rocket stockpile was performed, revealing that 21% of the rockets could not be separated with the existing equipment. This led to a decision to replace the existing equipment, resulting in the Vertical Rocket Cutting Machine, or VRCM. To address the potential for a leaking rocket and to minimize contamination in the facility, non-destructive examination technology was added to the OTA effort. All of the equipment is either already in place at the BGCAPP or on schedule to support M55 rocket destruction operations. The destruction process begins when the rocket is transported from storage to the main plant's unpack area. Inside the unpack area, operators prepare the rockets for evaluation by the Rocket Non-Destructive Examination System, or RNDE. The RNDE allows operators to safely perform an X-ray examination of the rocket warhead to determine if agent has leaked from the agent cavity of the warhead. Leaking rockets will not be fed to the process to minimize agent contamination within the plant. The leaking rockets will be processed whole in an on-site static detonation chamber, or SDC. The RNDE process begins as operators load 5 rockets onto an input cart. Care is taken to ensure the rockets are not rotated from their original storage position. This ensures agent is not distributed along the inner walls of the rocket's interstitial space or along the walls of the shipping and firing tube, or SFT. This keeps the leaking agent together in a single collective volume, providing optimum detection conditions. The carts are color-coded. White carts are for input of rockets to the RNDE, and green carts are for scanned and cleared rockets. The carts are constructed in a manner that prevents placement into the incorrect RNDE staging position. Once a cart is loaded, it is inserted into the RNDE staging position along with an empty green output cart. The system locks the carts into place, preventing removal until the scanning process has been completed. The RNDE gantry robot moves into place and picks up the first rocket and delivers it to the SFT motion sled. The sled tilts to an angle designated by the operator and moves the rocket into the X-ray unit. The operator may establish a tilt angle of 4 to 10 degrees to assist the operator in evaluation of the warhead. Once the X-ray scan is completed, the image displays on the operator's high-resolution display. The operator reviews the image and evaluates it for any potential leaks. The most common leak location is the interstitial space between the rocket motor and warhead. An additional leak location is known to be at the rocket's nose closure. If a leak is detected, the operator rejects the rocket using the Human-Machine Interface, or HMI. It is then moved back to the white input card, and an indicator light illuminates red to signal the operators that a problematic munition is present. If no leakage is detected, the operator accepts the rocket using the HMI screen. This signals the gantry robot to retrieve the rocket from the SFT motion sled and transfer it to the green output cart. Once all rockets have been examined, the carts are removed from the examination cell. Rockets on the green output cart are now fed to the rocket processing system. Any problematic munitions returned to the white input cart are overpacked and returned to storage until processed in an on-site SDC. Having been cleared by the RNDE, the rocket is fed to the process and travels to the VRCM. At the VRCM, a robot picks up the M55 rocket and places it into the VRCM. The VRCM makes the initial cut through the shipping and firing tube, or SFT. The SFT section is removed and placed onto the transfer station. The VRCM then cuts through the rocket, separating the warhead and rocket motor. The entire process is continuously monitored by an operator located in the control room. The empty SFT portion and rocket motor are destroyed by a separate process. The warhead is placed back into the conveyor where it travels to the explosive containment room, or ECR, where it is punched and the chemical agent is drained and destroyed in a separate process. Once drained, the warhead is wrapped in plastic to minimize agent contamination in the area. The wrapped warhead is placed into a canister. A plug is inserted, and the canister is sealed using 1,980 pounds per square inch of pressure. The seal is evident by the circular indentation visible at the top of the canister. The sealed canister is passed from the ECR into the next room, where it is scanned and a barcode label is attached for tracking purposes. The canister is now loaded onto an autonomous mobile robot, which safely transports the canister to the skid loading station. At the skid loading station, a robot places the canister into a specially designed skid. Once the skid is full, a barcode label is attached to the skid for tracking purposes. Prior to leaving the plant, the skid is monitored for chemical agent and then transported to storage until the warheads are destroyed. The drained rocket warheads will be destroyed on site in an SDC. The SDC is a heated chamber that will be maintained above 1,000 degrees Fahrenheit. Warheads fed to the SDC will heat to their auto-ignition temperatures until detonation, deflagration, or rupture occurs. This video footage is from an operational SDC. However, the destruction process is similar and will begin with containerized warheads being remotely unloaded from the skid and packaged for feed to the SDC. Up to 4 canisters may be loaded per feed box. The feed box moves to a lift, and the box travels to the top of the chamber and is loaded into loading chamber 1. The feed box is transferred to loading chamber 2, which is positioned directly on top of the SDC. This loading chamber provides both a seal to the opening of the SDC and a means to introduce items to the SDC for processing. To feed the warheads to the SDC, loading chamber 2 is rotated, allowing the box to slide directly into the SDC through the opening in the top. A timer is activated upon feed, and sufficient time is given to allow the warheads to heat and activate. The process is constantly monitored in the SDC's control room. As warheads are processed, residual scrap collects in the chamber. When full, a scrap dump is initiated by rotating the chamber to empty the scrap onto a scrap conveyor. Once emptied, the chamber is rotated and raised back into position. Once locked, it is ready to continue processing. Scrap is inspected as it moves off the conveyor. To process leaking chemical rockets that have been placed in overpacked containers, the original strategy required personnel to dress in personal protective equipment and enter a toxic area to remove leaking rockets. With the SDC-2000, this operation is eliminated. The SDC-2000 is currently under construction at the BGCAPP and will be used in conjunction with the existing SDC to destroy containerized warheads. The SDC-2000 will also be capable of processing a complete overpacked M55 rocket. There are 2 notable differences in the SDC-2000 and SDC-1200. The SDC-2000 chamber is larger and has a larger opening. This allows for the feeding of completely assembled M55 rockets that have been previously overpacked and cannot be processed by the rocket processing system. In addition, the locking mechanism for the upper and lower chambers have been redesigned to use hydraulic clamps instead of a locking ring. This process is a significant improvement from the original process, providing a safe operation for destroying an extremely high-hazard chemical munition.